3Ms, we're on our exponential functions unit, and we're going to start graphing some today. So when you are in class, we're going to get into groups of 2 or 3, and on some very large grid paper, I'm going to have you do 2 of the following functions, and I'll assign them to your group. So you're going to need to create a table of values and see what these look like. I'm going to show you a few in a moment, but I really want you to master a couple of by yourself so that you get a feel for what they look like and how fast they increase or decrease. So I'll let you do that in class, but for now, let's have a look at a few of these ourselves. So we've been talking about powers, and if we're going to graph a power, then it has certain characteristics. For example, if you have the power y equals 2 to the x, that means as x gets bigger and bigger, then you are going to double. If you had y equals 3 to the x, each step you make in the x direction, the y values are going to triple. Conversely, if you have y equals a base of a fraction to the x, that means as you go to the right and x gets bigger and bigger, things are going to halve, and so on. So I think for the sake of this graph, I'm going to do 2. I'm going to show you y equals 2 to the x and y equals 1/2 to the x, and we'll make a bit of a summary. If you have y equals 2 to the x, we remember from our powers and from the table of values that you just created with your friends that 2 to the 0 equals 1. So y equals 2 to the x has a y-intercept of 1. And as you travel to the right and x gets bigger and bigger, things are going to double. So from 1 we double to 2, and 2 we double to 4, and 4 we double to 8, and so on. And you've seen that in a table of values. Coming from the left, we know that things are going to have doubled to get to where they are, so one place to the left, it must have been at 1/2, so it could double to get to 1, and so on. All right, it's not lining up very well, but our function will look like this. Things are double as you go to the right. Notice towards the left, it never quite touches 0. Whereas the function y equals 1/2 to the x, you know that 1/2 to the 0 also is 1, because anything to the 0 is 1. It also has a y-intercept as 1. But as you travel to the right and x gets larger and larger, then each consecutive value things are going to halve. 1/2, 1/4, and 1/8, and things will halve as you go to the right. So we know that the value before that y-intercept must have been 2 so that it can halve. And it must have been 4 before that, and must have been 8 before that. So if you have a fractional power, it is a decreasing function. If you have a number larger than 1 as your base, it's an increasing function. And we call that exponential decay and exponential growth. Let me just tidy a few things up and we'll just write a little summary. So, unless I start doing some weird stuff, they all have a y-intercept of 1. That is very helpful. If b is larger than 1, then it is increasing, and we call that exponential growth. If b is a fraction between 0 and 1, then we have exponential decay, or a decreasing function. I'm just going to write my 2 equations over here. All right, if b is between 0 and 1, so a fraction that's less than 1, then we have decreasing function, or exponential k. And you can see the different shape there in the green and the red. The domain for both of them is that it goes forever and ever to the left and to the right. You can have any value for x, and we could find a value for y. So the domain, x can be any real number. The range. Notice that as far as the up and down goes, this is always greater than 0. You don't have any values that are 0 or negative. So my y is a real number, but it must be greater than 0. So for our basic functions, we have these 3 key features to keep in mind. And then our basic shape, we remember increasing and decreasing. The larger the value of b, the steeper it's going to be. Now we learned a lot about quadratics, and we learned a lot about transformations of quadratics. If I gave you this equation, you would all be able to tell me that that 2 is going to change the step pattern and make my quadratic skinnier or steeper. The same thing is going to hold true about the number I am multiplying 2 to the x by. If I am multiplying it by 3, I am increasing the steepness of this function. So let's have a look at what happens to that one. So I'm going to do a quick table of values. I'm going to do the function 2 to the x because we looked at it very briefly, and then we're going to compare that to what happens when I multiply the whole thing by 3. So we'll do -2, -1, 0, 1, and 2 just to get an idea. 2 to the 0, I'm going to do the easiest one first. Anything to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. If I have a negative exponent, it means flip. 2 to the -1 is a half. 2 to the -2 is a quarter. We're going to need to get used to what these look like. So my 2 to the x function that we just looked at a moment ago has y-intercept 1. It has values 2 and then 4. It would keep doubling, 8, 16, and so on. As you go backwards, half, quarter, eighth. And there is y equals 2 to the x. What happens when I multiply by 3? So I take each one of these values and multiply it by 3. 3/4, 3/2, 3, uh-oh, my y-intercept is different, 6, and 12. So the points that I see are, instead of 1, it is now 3. Instead of 2, it's 6. Instead of 4, it's 12. About right there. To the left, I have 3/2, which is the same as 1 1/2. 3/4 instead of 1/4. So it's going to lie just above, and so on. So it is like I grabbed my green function and pulled it upwards times 3. So it is the same idea as with a quadratic. If I multiply, I'm going to increase how steep it is. It also changes the y-intercept. It is now 0, 3. That's a comma, sorry. Okay, we're going to do 2 of these together. What happens when I put +3 up with the exponent? That would be the same as putting it in brackets. So I could write that as 3 to the x plus 3. So that +3 is glued to the x. When you have something up inside the function, or with the x, or in brackets, we have a horizontal change. And you know that horizontal changes are a little bit strange. This should move my function to the left 3. So using the transformations that I've used with quadratics, I am going to write y equals 3 to the x, and then move everything to the left 3. 3 to the x has a y-intercept of 1. I know that everything's going to triple as I go to the right. So I have point 1, 3, oh, fast, 9, and I've run out of space already. 1/3, 1/9, and so on. So for the function that I was given originally, y equals 3 to the x plus 3, I have everything moved over 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, and it would have the very same shape otherwise. That is not my puppy you hear. I would never bring a dog into the school. All right, there we are. We'll summarize these transformations in a moment. Let's try this second one. It says 2 times, I'm going to go to the bottom one, 2 times 3 to the x plus 4. So I know what 3 to the x looks like. I'm going to draw it first. It would have a y-intercept of 1, and everything would triple as we go to the right. So 1, 3, 9, 1/3, 1/9, and so on. There we go. Then I have 2 things happening to my function. I have this 2, and I know that's going to make everything steeper as if I pulled on that function twice as high as it was before. So y equals 2 times 3 to the x is going to have a y-intercept of 2. And instead of a 3 next, it's going to be 6. Instead of 9, it's going to be 18, but I can't fit that. 2/3, it's going to fit right in there. Oh, I'm so sorry, it's so crooked. Okay. Then when I have the plus 4, so this plus 4 is not up with the x. It is outside, so it is a vertical change. This is a vertical shift up 4, just like with our quadratics. So I'm going to take the blue one and move everything up 4. So this is 2 here. It's just hard to see. 1, 2, 3, 4. So it's now at 6. So my y-intercept, because I've had 2 changes, is now at 6. Take the next point and move it up 4. And the points way down here are up 4. And we would be approaching this line that's up 4. And it's not a bad idea to draw it because we're never going to hit it. We're just going to get very, very close. I'm going to get, oh, sorry, I want to just quick summarize this. All the transformations are the same as we had in quadratics. If you change this a value, it will make it steeper or less steep, depending on the value of a, could make it upside down. The plus h will move it to the left or to the right. If it's plus 3, we moved it left. If it would be subtract 3, it would be 3 to the right, backwards, because it's a horizontal change. And lastly, this k is a vertical shift. This was also a horizontal shift. Sorry, vertical shift up or down. It would be up if it were plus 4. It would be down if it was subtract 4, as you would expect for vertical. So make sure you have a record of this. And I'm going to ask you and your friend to draw the one that's remaining on this page, -2 times 3 to the x. And then I'll have some from the textbook for you to try.